Did anyone have the bubble sort code from last time? Because since I'm working from home, I didn't. Just can someone send me bubble sort code? Okay, before we do the bubble sort, let's look at the data allocation. Yeah, Sarthak, yeah, put it in chat, it's okay. Only Sarthak, if everyone pastes, okay, already Arihant, thank you, Arihant. Okay, so this is for integers. Okay, no problem. We will work. Okay, so we'll just keep this aside for the time being. We will, when we need it, we will get it. Okay. So first problem that we would like to solve is we want to read. So earlier, the number of strings that we want to read, it is fixed. So now we want to use an approach where we don't know the number of names that we are trying to read. We don't know. It could be 50, it could be 100, it could be 1,000, whatever it is. So what we do is we start with an initial estimate. We start with an initial estimate. That let's say initial estimate is perhaps we may read 50 names. Okay, and then we read 50 names and we get if more than 50 names, then we would like to allocate more memory. Okay, additional, incremental, and when we do an incremental size, there are many approaches. Okay, you can double the size of the existing memory that we are already using, and so many. There are several strategies you can use. But one strategy is to, like, for example, increment it by a fixed size. So, yeah, let's see. So read names, we want to write a read names function. And for the sake of simplicity, I use what is called as a global variable. The scope of a global variable is the entire, you can use the global variable in the entire, anywhere in the program. That is its scope. I should increase the font size. How should I increase the font size? Control plus will do. Is it good now? Okay. So we start with an initial estimate and we are now using a global variable names. So read names. And the read names will return the number of names it has read. It returns. So the thing about global variable names is we can use it in main, we can use it in read names, we can use it in any of the functions. So where is the global variable allocated memory? I will, so there is a place called data section in the memory. In the data section, memory for global variables will be allocated. Perhaps in the next class, I will talk about fully about what is called as a scope and scope, extent, lifetime of a variable. So in that class, I will in the next class, on the Wednesday class, I will do that. So right now, what we are looking for is, there is already a nice question. Why names char star star names? So the reason is, yeah, it's a pointer to a pointer. So what we are planning to have is, we are planning to have an array of pointers. So this is an array of pointers. We would like to work with array of pointers. So if each of these pointers, they point to some space in the heap where a name is stored. Like for example, here it could be Anusha, and then the second name here could be pointing to maybe Rhythm. Okay, so on and so forth. All right. So and then in the names we want to store the base address. So there is so this is the names. So this is the names variable. Names variable, we want to, in the names variable, we want to store the base address of this array. What is the data type of each element? What is the data type of this one? This is char star, right? If this is char star because it is pointing to a character, then the type of this is char star star. Okay. Are you with me here? Yeah, it's a pointer to a pointer, right? It contains the base address of char star, pointer to a pointer. Char star star means pointer. If you just use char star, it's a pointer. And char star star means pointer to pointer. And we would like, and we are storing this array of pointers in the heap now because we don't know the size of this array of pointers. We don't know the size of the array of pointers. So initial size, initially we will estimate 50 elements, and then later we want to increase it to 75, and then later we want to increase it to 100, so on and so forth. And one more thing I would like you to understand here is there's a very close relationship between pointer and array. So you remember A contains the base address. A contains the base address of the array. So A of I means actually A plus I star. That is, you take the base address and then you add I. When you add I, you don't add actually I. If the data type is integer, then you add 4i to it. And if the data type is character, you just add I because the size of each character is I. And if the data type is double and if it is 8, then you multiply by 8 and add. So this A plus I, this is not, this can be just I, or this can be 4i, or this can be 8i, so on and so forth, depending upon what is the size, what is the element type, what is the element type, and plus does it automatically. The size of the pointer, it could be 8 bytes perhaps, I don't know. Are you all with me here on this one? A of I. A of I is nothing but star of A plus I. And this idea we have to use because when we use char star star names, we use names of I to access it. So I want you to keep this picture in mind. Okay. So we have int read names here, and then so what do? We say names is equal to, what is the initial memory we should allocate to names? What is the initial? So malloc init underscore estimate times size of char star. Are you with me on this one? That we are allocating. We want to allocate how much amount of memory we would like to allocate. How many character pointers we want to allocate? How many names? 50. What is the size of, what is the data type of each element? What is the data type of each element? Char star. So that's what we use. Size of indicates the amount of memory required to store a character pointer. Char star means it's a pointer to a character. You remember? So the array of character pointers is also in the heap. Because we want 50 such entries now. Because we want to allocate an array of character pointers right now. How many of you are with me here? We want to allocate an array of character pointers. And the size of each element, it is given by this statement size of char pointer. So that is our initial estimate. And then, so now what we do is while scanf percentage temp str is not equal to end of file. So yeah, so what do we do? So here we have char temp str max name size. Okay. So now that we have so on line 16, so what do we do? So temp int y. Okay. So, and then what do we do? Names. Are you all with me here so far? We found the length of the string. No, not necessarily. Memory, when memory that is allocated in the heap, they can be. No, right now it is number of names. Okay, we will do that. So number of names plus plus. Why are we using +1 for number of names? While I look on line number 20, why are we using +1? Does this make sense so far? This code, we are initially on line number 14. We initially are allocating 15 array of 50 character pointers. Okay, and then we are, for every string we read, we allocate memory, and then we are storing the base address of that string in the current name. Yes or no? Okay, let's try to do a GDP of this program and see. I really would like you to get this one. CD GCC. What is that string sort of C? Include string.h include std lib.h. These names is an array of character pointers. GCC bubble. GCC string sort of C. String copy. Okay, bhaiya. This one is font is small, na? Control plus works here as well. Huh? Okay, thank you. You are rock stars. Control shift. Nice. Thank you, Chinmay. So GDB we got out. We enable break read names run. Okay. So now see we are here. So now if you look at print names, okay. So in the memory, somewhere in the memory, so I am drawing the picture here. Somewhere in the memory, so starting from 260, For the sake of simplicity, let's there is some memory here. No, this is so let's look at one more thing. Okay. See, there is because if you declare names as an array, yeah, so this is names. The address of, maybe I will draw it here this way. So this is names. The address of names is, 5018. Let's call it as this is 5018. And names is 62, and names contain 6260. Names contain 6260. So that is, so 6260, this is the address at which some element is present, and then at 64 or 68, I don't know, print size of char star. Yeah. So at 6268, so something 6260, 6268, like that it will be present. And this is names 0, and this is names 1, so on and so forth. And what is the important thing, guys? So C doesn't need to know whether it is an array or a pointer. It just treats them as the same. So C treats A of I as A is the pointer, and it gets mapped out like this. This is how it gets mapped out. So this is the first idea. I told you C doesn't care about arrays and pointers. No, it's just our view. If you just use A of I, then A of I just gets mapped to A plus I, where A is a pointer, base address of the array. A is a pointer, base address of the array. No, we cannot do size of names. When we do size of names, we cannot get the size of the array, not possible. We only get to know the size of the number of bytes allocated to names to hold the address. We have to keep track of it separately, Aryan. We have to, in a separate variable, we have to keep track. Are you all with me on the picture that is being developed on the right top side? That the base address of the array variable, names variable, is 5018 is the address of the names variable. And when we did an malloc, we got a chunk of memory from the heap. So this is all from the heap. This is from the heap. Just focus on what I'm saying, okay? Because you are all going in n number of directions. And first step, are you with me on first step, that the base address, the address of the variable names is 5018. Are you with me here? Second is, when we did an malloc, a chunk of memory from heap got allocated. And the base address of that chunk of memory is 6260, and that is stored here. That is the second idea. Okay, that's the second idea. The third idea is so the type of names 0 it is it's a character pointer. Okay, it points to a character. Okay, and names is a pointer to an element, to an object which is of type character pointer. So what should its data type be? Names points to an object. Names points to an object which is of type character pointer. It's a pointer to a character pointer. So its data type should be char star star. Please remember, names is pointing to an object which is of type character pointer. So its type should be character point, char star star. That's the reason why we have declared it like this. Okay, I hope you are with me again here. This is the third point I would like you to remember. So later we will see names being a global variable, that is point 4. It is allocated in what is called as a data section. We will see later this one. And this, the fifth point here is, this is all heap. That memory is coming from heap. And since we are doing an malloc, are you all with the 5 points I mentioned here? Data section is in RAM. Yeah, it's a logical part of the RAM. So the 5 points. And then, so now we are doing on line number 18, we are doing next. Okay, it is asking for some name. Let's give Sarthak. Okay. And when we do that, next. So now if I print names 0, the address that I get is 6810. The address we are getting here is 6810. What is 6810? 6810, it is again somewhere in the memory. 6810, it is somewhere in the memory. It's an address where you are storing. Sarthak name is present starting from 6810. Does it make sense? So S is present at 6810. Where is A? A is present at 6811. R is present at 6812, so on and so forth. Is the memory map coming to your mind? Does it make sense? Just 1 minute. How should I move to tweet next? How should I choose? I want to select this. Okay, anyway, let's do this. P/X. See, for some time I will not look at your questions. I'm just trying to examine the memory. Is it already our string copy didn't happy? That's the reason we are having this. Okay. Now, anyway, let's, I just want to examine, I want to show that what is it exactly that is present at address 6810. We should be seeing a, we should be seeing S there. We should be, oh, not at 6810, we should be seeing this. Anyway, so the point let's kind of ignore last couple of minutes what I'm trying to do. But overall, you got the picture, right? Yeah, maybe print names 0. Let's see what happens. Yeah. Okay. So what happens here is when we have so names plus 0, names contain 6210 and 6260, and you end up printing from there. Okay. Are you all with me here? See, technically speaking, I want you to understand one thing. Technically speaking, when we print names 0, it should print 6810. Yes or no? It should not print Sardak. But GDB is clever. Yeah, GDB is doing it for us. Okay, so. Okay then. So now I want you to, once this picture is clear, so now you go next and let's say Tejas. And then if you see print names 1, print names 1 contains 6830. So 6830, this is the address. This is the address at which Tejas, memory for Tejas is given. Are you all with me with this picture that you are seeing on the right side on the whole? Shall we proceed further? Yeah, now Sardak and Tejas, they are on heap. Yep. Okay, good, great. So now if you're all with me, so let's keep going further. So let's go back to our original program. So the problem here that we get is and also on line number 26, should we return number of names or number of names minus 1? Number of names only. Okay. So, but there is one problem that we need to work. That is, let's say at the beginning itself, we will see if number of names greater than current size. Okay, so what we do is we initially have something like int current underscore size is equal to init underscore estimate current max size. Okay. If number of names is greater than current max size, then what should we do? Then we have to do what is called as a realloc. names is equal to realloc current max size is equal to plus is equal to what is that incremental size. So now we are incrementing incremental size. Does this make sense? So not realloc, malloc, realloc. So what realloc does is, yeah, we can make whatever init estimate is. What realloc does is, whatever the chunk of memory, can I remove this picture here on the right side? Okay. So let's look at the signature for realloc. Man realloc. So realloc pointer, yeah, malloc, realloc. Realloc function changes the size of the memory block pointed to by pointer to size bytes. The contents will be changed in the range from the start of the region up to the minimum of the old and new sizes. If the new size is larger than the old size, the added memory will not be initialized. If pointer is null, then the call is equivalent to malloc for all size. Okay. It must be written by, then the call is equivalent to free pointer unless it must be written in earlier called. No. I have some deep misconception. malloc doesn't allocate memory linearly. Did I ever say that's the reason it's called as a heap? Okay. So all we have to do is we have to give the, we have to tell realloc. So the memory pointed to by names, could you please change its size to this? Are you all with me? Here, line number 23. Is there any problem in the way we did line number 23? Whatever the data that it is there, it remains. That's the important thing. So if my understanding is right, no. We decrease the size also, it's possible. For the time being, we are increasing. In the heap, let's say this is the initial amount of memory that is allocated to names. We are trying to expand it. If this expansion is not possible because this memory is allocated somewhere to some other piece, then this whole thing gets reallocated to a different place where memory is available. Are you with me here? Please pay attention. What is the first thing? We try to realloc tries to expand the memory. If it's not possible, it tries to find an alternate place in the heap where that much amount of memory is available and copies the whole content there. Are you all with me here? Yes, no? Okay, so that's all, very simple. Okay, let's try to see how this works. Yeah, there is a question, wouldn't the copying be slow? Let's see. Okay, let's get some names. Sardak, Anika, Brahad, Jaini, Shivam, Mithanch, Nipun, Aditya, Vrinda, Vansh. I like human. Okay. I hope this doesn't crash, you know. Let's see what happens. Void print names. Mechanical. So what are the possible, what is, I thought all keyboards are the same. It's just that, you know, I am punching hard, hoping that the program will work. And I can save my face before all of you guys for all the theory I told. No? So you tell a whole lot of theory and finally the program doesn't work. That's realloc invalid exercise. See? So I am getting an advice GCC's. Yeah, there is, I don't see any. Let's see what is happening. This is the problem. Let's see if this works. Read names, realloc, old. Yay, got it. Okay. What changes did I make? So yeah, so that's see, there is I'm so when I code with all of you some boundary cases, I don't keep track of carefully. It's essentially, yeah, only 10. So this could be 11. It's all names are there. So anyway, so yeah, what is the question is very, see, how many of you are with me? It's very simple, right? Malloc initially gives you some amount of memory, and you try to work with that memory. If that is not sufficient, you go back and ask for a greater amount of memory using realloc. And if it can be extended in the heap, then realloc does the extension for you. So initially it tries for extension. Try extension. If extension doesn't work, the whole chunk is copied to a new place. That's all. If this whole, let's say this is our whole memory, and if this extension is not possible, then what happens is a new place is allocated and this whole thing is copied. Of course, when it is copied, only this part will be copied. The part where we wrote meaningful data, that is only copied, but the rest of the stuff where it's not copied, like this one, so this remains the same. This is copied. When will the extension not work? Because then later on you will see we keep making a series of malloc calls. So what happens is your heap memory just gets fragmented. So in order to give a different picture, let's do one thing clear. So this is your heap memory. This is your heap memory. You ask for memory, it gives this, and then you make a series of malloc and free calls. So during this process, what happens is, let's say, so like for example, in this particular case, so what did we do? Yeah, just pay attention, yes, everyone pay attention. This is your heap. You initially, in the heap, you allocated memory for 50 names. That is 50 char pointers. Are you all with me here? Yes or no? So now, after that, you asked memory for Sardak. And then you asked memory for maybe Vrinda. So these are all allocated memory here. And after some time, you asked for, hey, could you please give me memory for 75 names you wanted to extend? But then when realloc tries to extend, it figures out that this memory which is next is already allocated. It may not be exactly next, but it could be very close by. Are you with me? This extension is not possible. There's a problem here. So what happens is this whole thing, it will try to find a place where it can hold 75 names and then copies the first 50 because the content needs to be kept. Okay, copy of this and the rest, these are the rest 25 names. No, when we do a realloc, it has to be, whole thing is a chunk. When a single realloc or malloc, it will be chunk. This Sardak and Vrinda, they are not next to it. They need not be next to each other, but everything Sardak has to be, you don't want to split Sardak into SARTHAK and put it in different rooms. No? That will be very unfair for Sardak, no? Not even for Vrinda. So Sardak has to be together, Vrinda has to be together. So human also agrees to this because he is human. 50 names. So 50 names, yeah, all 50 names, it's one chunk. You'll get it in one place. After this copy is done, this is released. After realloc, if it is gets copied to a new place, the original memory gets released. All 50 will be together, Sarthak. Vinkesh is saying buy CPRO. Huh? What happened, Vinkesh? Oh, so Amoga, all you will allocate memory for 75 names together. You try to extend. It's like this: you rent a home and you start getting overcrowded, and you ask for more space. If there is more space within that, no, next to your your home, you will be allocated. If that's not possible, all of you will be relocated to a new place, new colony, shift to a new colony. Exactly. Does it make sense? Okay. So now, yeah. So now the story is this. You understand now from this discussion, realloc is expensive. Yes or no? Because whenever it has to get copied, it is expensive. So what happens is, when you initially start with, let's say 50, and you try to go 75, and when you go to, this is the number of names, and you try to go to 100, when you go to 125, this is one way. The other way is you start from 50, you go to 100, and then you go to 200. This is the way, and then you go to 400. So between these two, which one is expensive? So the first one is expensive in terms of the number of reallocs that you make, it will be large. First case. For second case, the number of reallocs is less. But what is the problem? The second is, let's say if you require 200, and if the amount size of the data is 220 names, then what happens is in the you suddenly increment it to 400, then almost 200 units of memory gets wasted. Are you with me here? For 210 names, case 1, how many reallocs are required? Case 1, case 2. This is an exam question. Okay. Case 1, how many reallocs required for case 1 using this approach for 210 names? Something like 9, right? Yeah. I think around 9 maybe. How about second case? No, 50, 100, 200, maybe 3. Yeah, some 3 reallocs. So, but what is the memory space memory allocated here? Memory allocated here is 225. Memory allocated here is 400. You understood the trade-off? Okay, 8 or 9 approximately. Okay, so this is yeah, so that's all for today. So Noor is hungry. Are you all with me here? The big picture, did you get it? I think there are some questions you should be able to get it. I thought the last lecture is dumb lecture, so I didn't send it. Okay. It's okay. I think we should take a break. So I'll just go through the code and see. No, explain. You try to figure out the problem. No? It's like, no, I should not go peel a banana and feed you. You should try to figure things out by yourselves. So that's part of the learning exercise. Last lecture, Gaussian elimination, the whole content is good. I did a terrible job. So that's the reason I don't want to send it. Okay, then I'll send. Okay, so next class, linked lists. Okay. Okay, I will send it. I thought no, I didn't like my own lecture, so that's the reason I sent it. Yeah, I didn't send it to. Office hours today, you want it or not? Well, I don't have anything in mind, but